In 1938, the legendary Charles Boss Kettering and his team at General Motors' newly formed Detroit Diesel Division introduced a clean sheet design that would change the world. They created a new family of diesels that would outlive the companies that bought them, the trucks that carried them, and sometimes even the mechanics who rebuilt them. For over 50 years, the Detroit Diesel Series 71 engines became one of the most widely used diesel platforms in American industry, and that name still echoes in shops and shipyards across the country. This isn't just another engine story. This is the story of how American engineers created a diesel platform so fundamentally sound and so exceptionally reliable that it became synonymous with industrial strength itself. For more than half a century, the Series 71 engines defined what unkillable actually meant. The America of 1938 faced a problem that went far beyond transportation. Gasoline engines dominated trucking, but they were reaching their limits. They couldn't provide the torque required for heavy hauling, they burned too much fuel on long-distance freight routes, and they demanded more maintenance than industrial fleets could sustain. Diesel technology existed, but it was heavy, inconsistent, and complex. European designs were refined, but not suited to America's large-scale manufacturing or field service expectations. Many American diesels were still evolving and often too expensive or unproven for widespread use. The military, watching storm clouds gather across two oceans, needed engines that could be built quickly and repaired in the field by mechanics who might never have seen them before. General Motors wasn't looking for the most efficient engine. They weren't chasing the quietest operation or the smoothest power delivery. They were solving for something more fundamental: absolute dependability under conditions that would destroy lesser machines. Developed by GM's newly formed Detroit Diesel Division, building on Winton's engineering legacy, the design team made decisions that would echo through decades of industrial history. They started with modularity. The Series 71 wasn't one engine, it was a system. The same basic cylinder architecture could be configured as an inline 1, 2, 3, 4, and 6, and later V6, 8, 12, 16, and the less common monster 24V71. Each cylinder was essentially identical. The same pistons, the same liners, the same valves, the same injectors. This wasn't just elegant engineering, it was strategic thinking. A fleet operator could stock parts for one engine family and service everything from delivery trucks to marine vessels. A military unit could carry repair components that worked across their entire diesel inventory. But modularity was just the foundation. The real innovation was in the operational philosophy. Detroit Diesel chose a two-stroke design when most of the industry was moving toward four-stroke engines. This wasn't stubbornness, it was calculated engineering. The two-stroke design prioritized power delivery and mechanical robustness over refinement. It meant simpler maintenance schedules and more predictable service intervals. The scavenging system utilized a mechanical roots blower as a fundamental necessity for operation. Because the Detroit Diesel two-stroke cycle lacks an intake stroke, the blower was required to force fresh air into the airbox and through the cylinder ports to clear exhaust gases. Driven directly by the crankshaft via a gear train, the system provided a constant, reliable air supply, independent of exhaust pressure or electronic sensors, ensuring the engine could breathe from the moment it started cranking. The fuel injection was purely mechanical. No electronics to fail in harsh conditions, no sensors to corrode in marine environments. Just precisely machined components that delivered fuel at exactly the right moment every time for millions of cycles. The engineering philosophy went deeper than individual components. The two-stroke cycle simplified airflow management without adding additional cam-driven intake systems. Instead, intake ports were machined directly into replaceable dry cylinder liners. These liners were pressed into the block, providing a robust structure that could be pulled and replaced during an overhaul, returning the cylinder to factory new dimensions without ever needing to bore the block. This systematic approach to reliability extended to every aspect of the design. Because the intake was handled by the liners and the gear-driven roots blower, the rest of the architecture could remain modular. This meant a single set of tooling could produce components for any configuration. Mechanical unit injectors eliminated the need for separate high-pressure injection pumps and fuel lines.